Okay, let's get back to this. So I finally found a way to do this. So this page has the timing diagrams that were given with the exam paper, and this one has the question. So we'll do these one by one. So let's start with the part one. In part one, this is a D flip-flop, and that's given a clock with a negative, this ball, then inversion sign showing that this is a negative edge triggered flip-flop, right? And then it's fed in through D, the A input signal, and output is Q1, and O gate is given with the B signal for the output of R. So okay, so let's do this step by step. So let's first do the A and the clock to give you the Q1 output, right? So for the Q1 output, all we need to do is look at A, and then whenever there's a falling edge, look at what A is doing, and D will do the same, right? So let's go over to here, and then let's start this. I'm just going to draw this in blue. So let's write this as the Q1. Again, you don't get marks for drawing Q1, but I think it's a good idea. So now we're looking at A and the clock, right? So whenever we have a falling edge of the clock, right, we have a falling edge of the clock. So this point over here, this point over here, this point over there, this point, this point, this point, and this point, you need to figure out what D is going to do, right? And D is a very simple flip-flop. If the input is high, it goes high. Input is low, it goes low, and that's all, right? So in the question, you also told that you can assume that initially all of the outputs are low, so it makes it even easier. Okay, so let me just mark this over here. Okay, at these points we need to read. Okay, so initially inputs are low, so this just stays low, and then at the first falling edge, the input is high, so it goes high, right? So initially, I'm just going to draw this without a timing delay, and then we'll figure out the timing delay later. Okay, so there, and then the next one, A is low, so it goes low, and then what happens here? A is high, it goes high, and it goes low, and it goes high, and it goes high. It stays high, and it stays that way to the end, right? Okay, so right, that's that. So let's go back to the question, and then let's read up again and see what happens with the timing delay. So the period is 1 picosecond, right, and have a transition delay of 20 nanoseconds, right? So what happens here? 0.1 picoseconds is 100 nanoseconds, right? 100 nanoseconds, and 20 nanoseconds is the transition delay. Okay, so this is 100 nanoseconds. We have 1, 2, let's go between 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so one of these bars is 10 nanoseconds, so the transition delay is actually 2 of these bars. Okay, so with the transition delay, the output of Q1 should look something like this. It goes like that, there. So the green one is the output that we're getting with the transition delay. Okay, there, there. Okay, so that's what we should get. Okay, and just to make this a little clearer, I'm going to delete the blue parts so that won't confuse us. So that's what the output from Q1 should look like. Okay, now let's go back over here. Now we also need to give R is B O Q1, right? That is That is the output that we actually have to mark. Okay, so we need to go back over here and then let's put R, right? And so R is Q1 OB, right? So Q1 OB. So whenever Q1 OB is high, this should be high. And since gates, we can consider gates to be ideal, we look at Q1 and B, and whenever either one of them is high, this goes high, right? So here goes high, then goes low again, and then now here this part is high, so this goes high, 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 and low. Now high again over here, low, high, low. I'm sorry, this part is high, so it stays high, stays high. Now here it stays high, down there, up, and keeps on going. Right, so that is what the output for question number 1 should be. The part 1 from the question 4 actually. Okay, that one is done. Let's move on to the next one. Okay, in part 2, you're given a JK flip-flop. A and B are the inputs, and then the clock with the negative falling edge enabled flip-flop. Okay, so from this we have to give S and T, right? So let's work on S because S is actually going to be the input for the second flip-flop, right? So we'll do this part by part. Okay, so in this first flip-flop, we need to look at A and B as inputs, and depending on what they are, whenever there's a falling edge, that's when we need to look at it. Okay, so let's go back over here, and I'm actually going to draw some lines so I can see these falling edges. There, I'm sorry, wrong one. Falling edge from here, there, falling edge from there, 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 and a little bit closer. There. Okay. Okay, and go back over here. A and B. We're looking at A and B and falling edge. Okay, so this is going to be S. Okay, S is initially going to be that, right? And then we're looking at A and B here. A is high, B is low. So when J is high and K is low, it's at the set, so it goes up, right? With the transition delay of 2, so it goes up over here. Instead of going up straight, we're just going to put the transition delay straight, and then we keep on going like that till we get there. Okay, at this point, what's happened? J is low, K is low. That means remain the same, so it just keeps going like this until we get to this point. Then now what do? We look at A is high and B is okay. Now what do we, now this, it's when it's changing, right? So whenever it is changing, you need to check the state that it was before. So J is high, K is low. J is high, K is low. J is high, K is low, so it remains the same. And then here, low, low, so it remains the same. Then here, high and high, J is high, K is high, so it's toggle state. So it was toggle state means it changes whatever it was. If it was high, it goes low, and then stays the same. And then what do we have here? J is high, K is low. That means it's set. Means it goes high, and that is S. Okay, right, so S is done. Let's go see what T is again. So here T comes out from the second flip-flop. The second flip-flop, you get by getting S as the clock and VCC, that means J is high, K is high, it's always at the toggle state. So this one is always at the toggle state. You don't need to worry about the truth table, it's always at the toggle state. We just need to worry about when this signal goes from high to low, right? Whenever there's a falling edge, we need to just change the state. Let's go back over here and then let's write T, and then what we need to do is, right, T is initially 0 that we can get, right, and then we just need to see when S goes from high to low, so it's at this. So at this state, right, at this point over here, right at this point over here, we need to toggle the state. Okay, so it's low all this time, low all this time, and then at this point it goes high with a transition delay of 2 of these there. Okay, and that's it. So this is part 2. This one is 2 and this one is also part 2, right? So both of these together are part 2, and we're done. Okay, so I hope that was clear. Let's move to the final part. Final part is this one over here, and let's see what we have here. We are told that we have 2 flip-flops, both JK flip-flops, and in the first one we have A as J, okay, and then K is going to be the output from Q5. Aha, okay. So output from Q5 is going to be K, and then A is going to be J, right? Whenever you have a feedback like this, right, whenever you have a feedback like this, then you need to consider you need to consider both of them at the same time. So let's think about what this first flip-flop is doing, and then we move on to the second flip-flop during every transition. So the second flip-flop, what does it have here? It has J and K, right? J is from U, which is from Q4, and K is the opposite of that, right? But all of them work from the same clock. Okay, well, at least that is simple. So we only need to worry about transitions at those places, right? So J for the first flip-flop is from A, K is from the output of the second flip-flop, and that is from output of the first flip-flop. Okay, we have to do this very slowly now. Okay, let's see how much do we have enough space. We don't have enough space, so what I'm going to do is I'm actually going to erase some of the older ones. So I'm going to erase these, if that's all right. And yeah, so just erase all of these. Okay, and let's start with what do we have again? Q4, which is U, and B, which is that. Okay, so we'll have U, which is Q4, that looks at A, only, and output from V. Okay, so let's do this. So initially we are told that V is low, right? Because all of the outputs are initially low. We are told that. So let's keep this at low initially, and that means, so this is actually going to be the K for this one over here, right? So these two are the ones which are going to be, this is J for that and K for that, right? Okay, so for this first flip-flop output, it's looking at A and B. So we get to the first triggering event, that is the clock, and then it looks at A is high, so J is high, and K is 0. That means it's at the steady state, so it's going to It's going to be at 0 initially, and then it's going to go high. Okay, that goes high. All right, and then it's going to stay that way until the next trigger event. Okay, so don't look at this any further. We need to figure out what's happening with this. Okay, so this one, what happens? It takes this as the input for both j and the inverse as the output. Okay, so when it gets to here, what's happening here? J is low, k is high. That means that it's at the reset. That means this stays low. Right? I hope that was clear, because this one, the j for this is u and the k is u bar, right? So at this point, at the first clock, and it's triggered by the clock as well. So at the first falling edge, it looks at j, which is u. It looks at u, which is 0, and then it looks at k, which is u bar, which if this u is 0, then u bar has to be high. So in the first state, j is 0, k is 1, which is it means it's at the reset state, and it's going to output is going to turn 0. All right, then we get to the second clock, the falling edge. Now this looks at a is 0, and it looks at this, right? A is 0, B is 0. That means it's at the remain high state, and then it's going to stay the same the way through that. Okay, then we take a look at this. So this looks at u, j is high, k is low, so it's going to turn to the high state, and it's going to remain the same way all the way through to the next one. Okay, next triggering event, this looks at a is high, and k is also high. That means it's at the toggle state, goes down, stays the same until the next triggering event. This one, it looks at over here, it's going to look at j is going to be high, and k is going to be low, so it's going to stay high. Okay, here again it looks at a is low, and k is high, so it's going to be at the reset, so it's going to stay at the same, stay that way. This looks at u, which is low, k, which is going to be high, j is going to be 0, k is going to be high, so it's at the reset. This goes down and stays like that. Here looks at a is high, k is low, so it goes high, stays the same. Here this looks at j is low, that means k is high, and it stays low. And at this point it says, okay, what's a is high, k is low, so it's going to stay high, and here what happens, it looks at j is high, k is low, so it's going to transition to the high state. It should be a vertical transition state, and that is it. Okay, so the way that I assign marks for these flip-flop questions is, if you don't do the right transition delay, I don't deduct marks every time. You'd get deducted marks for having the wrong transition delay. But with these pulses, every time there's supposed to be a transition and you make a mistake, I will deduct some marks for any wrong transitions that you do. But this is not an overall, so if you miss one transition, the rest of it is alright, you still get some marks there. Okay, I think that's all. So I hope this helps. Again, if there are any questions, please feel free to comment on the Google Classroom, on the YouTube videos, or just email me, and I'm happy to help. Okay.